Good morning, students. I hope you all had a really great spring break. Now we are moving on to week 4 of online learning. I hope that I can see you all on Thursday through the video conference so that we can check in with each other and just see how you're all doing. But if you can't make it to that, if you have any questions or comments or you just want to message me on Schoology, you can. I will be available from 8 o'clock in the morning until 5 p.m. in the afternoon to respond to your messages if you need anything from me. All right, getting straight to our review video. So right now you are watching today's review video. I am going to be reviewing what we learned the past 3 weeks before spring break just to catch us all up again because I know you had a week of no online learning that you had to engage in. So I just want to do a quick review before we move on to a new concept that we'll go over tomorrow. So this is the week 4 slides that I'm looking at. I'm going to press present. So Arduino, it says the topic is still thermal energy transfer and your learning objective. It's written right over here. You will review the states of matter test questions and address any misunderstandings by watching the review video, which is what you're watching right now. And I will demonstrate my understanding of why a substance changes states by forming my own written explanation on the discussion board. So I'll go through all of it with you. So first you're going to watch this review video, which is what you're doing. And then when this video is over, you're going to comment on the discussion board and then retake the states of matter test if necessary. So what will you submit to me today? Today you'll submit your comment on the Schoology discussion board. And some of you, if you scored a C or lower on your test, you're going to submit your retake of this test for a higher score. All right, click here for next slide. It says, this is a review of what we learned from 2 weeks or around 3 weeks ago. So the question is, why did the balloon pop when placed above fire? So I just want to go over one more time that there are air particles in the balloon that are moving around with low kinetic energy. They're not moving that fast. And since the fire has thermal energy, it's a source of heat. The thermal energy transfers from the fire to the particles inside the balloon. And when that happens, these particles gain more thermal energy and this increases their kinetic energy, making the particles move around faster. This will make the temperature of the air inside the balloon increase as well. And because the particles are moving faster with more kinetic energy, they hit the walls of the balloon with more force, making it pop since the balloon cannot stretch anymore. So this is a review, and this slide is very important that you understand every single numbered sentence over here because this is how you will properly use the vocabulary words that we've learned. So I've underlined every vocabulary word, so if you can reread all of these sentences and make sure that you understand each word that's being used. All right, ready to move on? And these are some important words that we have to remind ourselves of the differences between these two words, thermal energy versus temperature. So temperature is the average amount of kinetic energy of the particles, while thermal energy is the total amount. So those are two different things. Temperature measures the average amount of kinetic energy of the particles, how fast the particles are moving, and thermal energy measures the total amount of kinetic energy of all the particles. So like we've said before, these are 3 smaller cups of hot chocolate. The thermal energy is the same in all 3 cups since they're equal amounts. So there's the same number of particles in each cup and they're all the same temperature, 100 degrees. So that means they all have the same thermal energy. However, when you combine these 3 cups of hot chocolate into this large pot, remember the temperature stays the same because temperature gives you the average. On average, the particles are still moving at the same speed, so the temperature stays the same, but the thermal energy of this pot of hot chocolate will be 3 times the thermal energy of each individual cup because you're combining 3 cups together. The total thermal energy will be 3 times more. And then how does matter change from one state to another? We learned that there are 3 states of matter: solid, liquid, and gas. And remember, even in a solid state, the particles are still vibrating side to side. So they still have thermal energy, they still have kinetic energy, but just very little bit of it. Let me go back to the previous slide. So remember, to go from solid to liquid, you have to add thermal energy, and this will increase the kinetic energy, and this will make the temperature go up. And this is actually the question on your discussion board today for homework, so make sure you listen very carefully. One more time, how does something like a solid, like an ice cube, melt and become a liquid? Well, you have to add thermal energy, which will make the particles move faster, so their kinetic energy will increase. And as they move faster, they're going to spread out a little bit more, making it melt and change into a liquid state because the temperature also went up. Now, how do we go from liquid to gas? Same thing, add more thermal energy, make the particles move faster, the kinetic energy increases, which makes the temperature go up. Now, how do we go backwards from gas to liquid? Remove thermal energy, which will make the particles slow down and decrease in kinetic energy, causing the temperature to go down. And the same thing from liquid to solid, you have to remove thermal energy, make the particles slow down, decrease in kinetic energy, and the temperature will go down. Now, on your states of matter test, there were many questions about this slide, and some of us got confused when it asked you, how do you go from solid all the way to a gas? Well, same thing, you have to add a lot of thermal energy to go from solid all the way to a gas. Now, how do you go from a gas all the way to a solid? Well, same thing, you have to remove thermal energy. Just like you have to remove thermal energy to go from gas to liquid, you have to remove thermal energy to go from gas all the way to a solid. Now, what are these phase changes called? This was on your test, and it was just a matter of memorization. So, solid to liquid is called melting, liquid to gas is called evaporation, gas to liquid is condensation, liquid to solid is freezing. All right, so that's the end of our review. And before you can go and comment on this discussion board, I want to review the test that you all took. So the week before spring break was online learning week 3. So it's in this yellow folder. You were supposed to take this test, which was due April 4th. Now, many of you did a really great job on this test, but I also noticed that a lot of us got a very bad score. If you got below 22 points, that means you got a C, D, or an F. And remember, we're all trying to get an A or a B. So if you got a low score, you want to retake the test. Now, before you retake it, I'm going to help you and go over the questions with you. So for question 1, it says to go from a solid to a liquid. To go from a solid to a liquid, thermal energy must be added or removed. Well, in order to go from solid to liquid, the particles have to move faster. To make them move faster, you have to add thermal energy. Question 2, to go from a gas to a liquid. So you're going from the particles moving really fast, and now you have to make them move slower to go back to liquid. And to do that, you have to remove thermal energy. And how about to go from a solid all the way to a gas? Well, if you want something to go from a solid all the way to a gas, these particles have to move so much faster. So that means you have to add thermal energy. All right, and then to go from liquid to solid, well, you want the particles to move slower, so you must remove thermal energy. Okay, so I'm gonna stop there. I'm not gonna go over all of them with you because I do want you to try on your own, but I went over 4 questions so far, and let me go over these ones. You have to just memorize and know these words. So as long as you check the PowerPoint slides, you should know it. But I do want to go over the question with the paragraph. This one, question 11. It says fill in the blanks with the correct word from the word bank. You can click on the blank you are filling out and then click on the word from the word bank. So you don't have to type your answer. You can just click on the word that you want. So blank number 1, it says when thermal energy is added to liquid water, when thermal energy is added, the water particles will move blank. When you add thermal energy, the water particles will move faster. They have to move faster because you're adding thermal energy. blank number 2, the increase in the average blank of each particle. So if the particles are moving faster, there's an increase in the average kinetic energy. Remember, kinetic energy is the energy of motion. So if they're moving faster, there's an increase in the average kinetic energy. Now let's finish the sentence. The increase in the average kinetic energy of each particle will increase the blank of the water. Well, what measures the average kinetic energy? What measures the average kinetic energy? That has to be temperature. So temperature will increase. Now, as the kinetic energy of the particles continue to increase, the water will change states from, well, the water is first in liquid state, and now it's going to change to what? If it's moving faster, it's going to change to gas. And what do we call this change of state? Well, when you go from liquid to gas, you learn from the PowerPoint. Liquid to gas is called evaporation. So you should know that it's evaporation. All right. Now, question 12 is the same type of question, but it's going backwards. Now it's telling you if you remove thermal energy, what will happen? So this one you should know. I'm not going to do it for you. You can figure this out. And remember we said that when a substance changes states from solid to liquid, when a substance changes states, does the number of particles in the substance change? When you go from solid to liquid, does the number of particles disappear or go down or go up? No, the particles stay the same. The only thing that changes is how fast they are moving. So this has to be false. Question 14. When a substance changes states from a liquid to a gas, the particles will move far apart. Is that true or is that false? You should know. Question 15. When thermal energy is added to a liquid, the particles will move faster and increase in kinetic energy. Is that true or false? You should know. And question 16. Again, same thing. If thermal energy is removed, they'll move faster and increase. Is that true or is that false? So that was our whole test. So you should have all of your answers and check that you answered everything. If it says no answer provided, it means you're going to get a score of 0. Once you're ready to submit, you can press submit. So that was the review of the test. Now going back to our PowerPoint. Now your homework for today is to comment on our discussion board. So follow these directions. If you go to your materials page, you're going to see States of Matter Final Review, the discussion chat bubble. So you're going to press that. And then you're going to read the directions and comment with your answer. So the question is, why does ice melt when placed on a warmer plate? It's very similar to the question that you saw in your test. You have to use all of the following words when writing your explanation. So when you type your answer to this question, you should use all of these words for full points. So you can type your answer and say, ice melts when placed on a warmer plate because, and then type your answer and make sure that you correctly use each of these words in your explanation. All right, and when you're done with that, the next one is to retake the States of Matter test. So if your score was a C, D, or a F, if you got between 0 to 22 points out of 28, then I'm giving you a second chance. So if you want to retake your test, you can study and retake your test today. So to retake your test, you're going to go to the materials. You can click on this, retake States of Matter test, and take your test one more time. And say that you got a B or you got an A-, and you know you can do better, then you can still retake it. So I'll just count the higher score. So if you want to retake it, you can go and retake this test today. All right, so that's the end of today's lesson. And then tomorrow we're going to be ready to start our new lesson, and I'll have some demonstration videos for you all. All right, please go and do your discussion board and then retake your test now.